enthalpy of formation is the amount of heat that's going to be released or absorbed when you're forming a compound. There's a couple specifics you have to look out for. Make sure you are forming 1 mole, just 1 mole of a substance. You are forming that substance from elements, not from other compounds. And these elements have to be in their standard state. So standard state is how something would exist if it was at 298 Kelvin, so 25 Celsius, and 1 atmosphere. So basically, what would a substance be like, what would an element be like at room temperature and pressure? So I know the standard state of oxygen is going to be a gas, because oxygen is a gas under those conditions. I know that carbon would be a solid, because graphite is a solid. So also the reaction has to occur under standard conditions, so that's at standard, the 298 Kelvin and 1 atmosphere. Notice it's a little bit different than STP. STP was the 0 Celsius and the 1 atmosphere. So standard conditions for thermodynamics, just slightly different. Okay, so let's look at a couple equations and figure out if they could represent the enthalpy of formation. So for the first one, I have ethine and oxygen making carbon dioxide and water. Well, first of all, I'm not making a mole of any substance, so I know this is not an equation representing the enthalpy of formation. So this is just the enthalpy of reaction, just our Xn. And here, I'm making carbon dioxide, so that's better than this one. At least I'm making 1 mole of a compound, so I'm forming 1 mole of a compound. And I'm starting with carbon as a solid. Carbon's a solid at room temperature and pressure, and oxygen as a gas. So yes, this could be a reaction representing the enthalpy of formation. So this delta H could be a delta, this not means that I'm at standard state, not as the little circle, and F for formation. It could be. And for the last equation, I'm making a mole of water. That's good. And I'm starting with oxygen as a gas. That's good. And liquid hydrogen. I've never seen liquid hydrogen. I know there's gaseous hydrogen in the room. So no, hydrogen's not going to exist as a liquid at room temperature and pressure. So this equation is not representing an enthalpy of formation, just this one. However, it's missing some information. Somebody would have to tell me in this equation somewhere that this would be under standard conditions. This would have to be solid carbon reacts with gaseous oxygen at 298 Kelvin and 1 atmosphere to produce 1 mole of carbon dioxide. And then the change of enthalpy for that reaction would be the change of enthalpy of formation. So that equation would be telling us the change of enthalpy for formation of carbon dioxide. Okay, so you might wonder, how do we use enthalpies of formation if we're talking about them? One helpful thing, we've been looking at enthalpy of reaction. Enthalpy of reaction is how much heat is released or absorbed during a reaction. We can use enthalpies of formation to calculate the change of enthalpy of a reaction. Or you could use the enthalpy of reaction and all of the other enthalpies of formation to calculate the enthalpy of formation of one of your reactants or of one of your products. So what you look at is how much enthalpy, usually enthalpy is given off. So how much enthalpy is released when you form the products versus how much enthalpy is given off when you form the reactants. And the difference between the two is how much enthalpy would be released as you went from reactants to products. So it would be the change of enthalpy of reaction. And something that might show us that a little bit better. Let's imagine that we are climbing mountains. So this first one is 2,000 feet high. It's 2,000 feet above sea level. So we're comparing all of the elements at standard state. We say that they have 0 enthalpy, because to form an element at standard state from elements at standard state, there's no reaction, no enthalpy will be given off, no enthalpy will be absorbed. So the enthalpy of formation of all elements is 0. So we have a baseline of 0 for all of the elements at standard states, and then we compare everything to those elements in the reaction. So we talk about the enthalpies of formation of all the reactants and products. So here we could be saying, here's this one is 2,000 feet above sea level, this mountain is 2,500 feet above sea level. So I look at the difference between the two. To go from this peak to go up to that peak, I have to go up 500 extra feet. Just like saying if a certain amount of enthalpy was given off from the reactants versus given off from the products, the difference between the two is that when you go from the reactants to the products, you are giving off an extra 500, let's say, kilojoules.